Hello, everybody. Thank you for tuning in. Another video of things that you don't always see on this channel, because I do a lot of mechanical stuff, but my other passion is vintage electronics. And I'm going to be repairing a vintage Heathkit SB 220, and they are used for ham radios. And I have an older gentleman that I try to keep stuff going for, and this goes on some of his equipment here that he's going to be running. And he asked me if I could upgrade this unit. So what we're going to do is we're going to do this Harbach board kit, and we're going to get the amplifier on the bench. We don't run these, by the way. You have to have a ham operator's license to use these, but I do work on the stuff. I know a lot about it because of the other radios, two radios and television sets that I've worked on over the years. And so I've got this board has already been, pre-printed and laid out. We've just got to assemble the components and do the soldering, and then we've got to retrofit it into the old unit. And so I hope you hang out, and this is informative, maybe because I don't actually see a lot of this stuff on the internet. So maybe there's a lot of SB220s running around right now. A lot of people trying to fix these things that could use this help. So don't forget to hit the like, and don't forget to subscribe, and always share this stuff out on Facebook and help me grow this channel. So stick around, guys. Thank you for watching. So we've got some stuff already laid out. These are some of the components also that'll be going into this board, and more than likely we're going to do this soft start. The problem with these soft starts that I've had with the Harbach kits is the relays tend to hold up pretty good. We may or may not put that in there. I don't know. I'll ask the guy if he wants to do that. I have it here, but I usually upgrade these to 20 watt resistors because I've had the 10 watt resistors that have burnt out before. One side always seems to do it. I don't know why, but you'll get to flick it on and you'll lose half your leg if it's running off 220. But first of all, when it comes to capacitors and assembling them, there's a couple ways that I identify polarity. This one's marked with a negative line. That's a really good indicator, but some of your ones that are radial, they'll have one lead that's longer than the other, and typically the longer lead is positive. And if it's an axial capacitor, a really good indicator of that is looking at the axial capacitor. The side that has the insulator is your positive side, and the negative side is the one that's like made into the outside metal can shield, where you see a lot of the silver right here. If you see this kind of material in an axial capacitor, that's typically positive. You've got to have these in the right way. If you put them in backwards, you're going to have a mess on your hands. So this will be, we're just going to go ahead. These are the easiest things to lay in there to get this started. So we're just going to go ahead and make sure we put these in properly. They're just little snap-ins. So we'll put these in real quickly, but being very careful at the same time. Then we'll flip it over and we'll solder it in. I always double check, especially when I'm in a hurry. So let's make sure we want to, that's it there. We'll kind of try to keep the video short and sweet. And you may know a little bit about this already, but there's people out there that are kind of new and they want to learn this stuff. So hopefully I can flip this over and everything stay put. I have a trick for that with a piece of cardboard, but I don't have that cardboard with me. So like I say, I may double check behind myself, make sure we're right here and right there, because you don't want to put these in backwards. No, you don't. You really don't. You want to make sure that you're laid out right, because if you do, you've got to see like that one there. I had it backwards. You want that right. Otherwise, you have a mess on your hands. Hopefully, I can make that. Should I edit that out? All right. Let's see here. There we go. All right, so we've got it flipped over, ready to do a little soldering now. Bust out our trusty. They make thicker solder than this, but this works for it. I don't mind just filling it in. It's okay with me. So we'll solder this all in. A little bit of heat transfer. Go ahead. There we go. So there's our soldered in unit for the capacitors anyhow. That's a good start. You can see how the solder should look. You know, you want it to flow and lay over top of your points perfectly. And as you can see, one's one way, one's the other, one's the other, and then so forth. And then we're going to open this package up and then install the diodes. And I'll probably leave these off the board just a little bit. In D8, you know, and you can see that this board is actually kind of laid out nicely. It shows you which end is for your banded end, because the diodes are designed to make alternating current go one way, like a check valve for AC current. And we're going to be rectifying AC current coming off the high voltage transformer into DC current, and had this capacitor bank for reserve filtration and also to up the voltage a little bit, because when you run through capacitors and diodes, you actually get typically a 1.5 increase in voltage. And so we're going to lay these out. And then you also are going to have some bleeder resistors that are going to go in over here. And what they'll do is they help to equalize the voltage across the capacitors. That's a big deal. If you don't have bleeder resistors, which some of your older amplifiers and RF equipment didn't, but you had a higher rated voltage capacitors. These are really big. These are 220 microfarads. That is a lot at 450. These are actually really good capacitors. But anyways, it used to be 500, 550, 600 volt capacitors back in the day. And they could take that. You know, what happens without bleeder resistors is you'll get a surge of current that usually typically idles on one capacitor and makes that one really run higher voltage. So these bleeder resistors not only bleed the system down once it's been shut off, so it's not just sitting there with high voltage in it all the time. It also helps to equalize voltage across all these capacitors so that they kind of all run the same. And it just helps stabilize things. So they actually serve many purposes. And so we'll go ahead and, being the fact that we've already know that these lay out this way, these are going to be sort of in a line too, by the way. I don't know if you can see this or not, but these diodes are going to be in a line, and they split actually in the middle. Right here, you're going to have an input point right here, and they'll split. And this is one for one and one for the other, and it kind of is a way of kind of doubling the voltage a little bit. It's that's kind of what they call that, a voltage doubler. So let's go ahead and get these laid out in there, and we'll do that. So to get these to look, we're gonna try to make this look good. I want it to never turns out like I want it to, but we understand. So we're gonna go right to each end, and typically I'll just bend these down about right here. Hopefully see how that looks on the first one there. Not too bad. That's not bad. That's not bad. I'm fine with that. Yeah. So we'll make the rest of them all look like that. Then we'll kind of lay them out. Let's see. I'm just kind of just a little ways off the end of that. You can see. And I'll just bend it down. Get pulled over with these in your car, and cops like, "What are you doing with these rope clips?" I'm like, "No, sir, it's not what they are. These are for. I actually use these for not that." Just gonna bend these and stuff, and so then we're just gonna lay them out, and I'll just do that. And to keep the video from being 10 million minutes long, we'll just cut that and come back to it. Once I find my where I want them to be at, I'll just take and just kind of bend them out just a little bit, so when I flip the board upside down, they stay put. That's not that. I like that right there. Oh man, let me get it in camera there. But see that? That's pretty good. I like that. So we're just gonna run along and do those like that. I'll move this one over into here. I want them to kind of all sit the same. So, and like I say, having them off the board a little bit provides a little bit of ability for these things to cool off a little bit. Maybe run a little cooler. Now, there's a time and place that you don't want to do that when it comes to. Especially when it comes to like HF transistor amplifiers, you don't want to, there's certain resistors, you want to keep them as short and as close to the board as possible, because you don't want an interference of an unwanted capacitance. But that's not the case here right at this point. We're just rectifying some voltage here. So we're going to, like I say, we want these things to kind of all have a little bit of room to breathe, I guess you would. So I'll go ahead and do that. We'll start soldering. This is kind of what it looks like pre-solder. That's what it looks like right there. This is why I wanted to put the capacitors on first, so I have a little bit of standoff. And I just want everything to kind of lay out nice and pretty. And I try not to solder both ends of these, because I'm going to be putting a lot of heat. My soldering iron is at 473 degrees Celsius, which is quite a bit in Fahrenheit. I'm not a mathematician, but anyhow. So I'm going to solder one lead, move on to the next, and kind of stagger around to keep from heat soaking the diodes with my soldering iron, because they're going to get hot. If you were to flip it over and see the other and touch the other side, you'll know what I mean. So I want this to, I heat the thick part first, which is the lead, because it takes the most heat. And so I'm gonna go on to a different one over here, let that kind of cool off a little bit. That way we don't superheat the thing. Might be all right, but it's just a practice I did, especially working with smaller components that definitely won't take the heat. And you also got to be really careful too, not to heat your trace up too much, because you can make your trace lift off the board. So basically, we're just going to keep doing that, and just moving around, not overheating each component. And I may take my clippers and clip some of the leads out of the way as I go along with this, so that I can get around. And having the lead already long before I solder it, believe it or not, gives the excess heat sometimes a little bit of a place to go. That's a neat thing too. Some small components I'll actually clip these on when I solder, because then this will actually take the heat instead of the component that's in front of it. A little tip while we're messing around. So let me get this all soldered in. By the way, if you can find a pair of these, that's a must-have. I swear these are, but I can't find these anymore. These are kind of becoming a relic of the past. But they make other models of clippers just for the heck of it. They look kind of like these real, my Save the Tatas. They pink like they are, but they got a real nice fine point. A couple of different pairs of these, like this right here. They got a really nice point and can get into tight places. And I'm just gonna let it go along, and that one's there, but it's got soldered to it. But like I say, people don't realize too, you need to be really careful when you're moving these components around, like not to grab something and pull up on it, because you're liable to pull the trace off. So you got to be mindful of that. And watch your eyeballs with this. Sometimes these little things come flying off and they hit you in the face. So now we've got that all nice and soldered in. I don't know if you can see what that looks like, but that's your rectifying diodes strung in a line. You'll get a voltage feed in right here and right here. You can see one side goes into the capacitors, the other side's coming in, so your transformer is going to be feeding these 2 points. Then our bleeder resistors will go in, I do believe right here. I haven't looked at the manual, but I'm going to check that out. You got some other resistors in line here. This is actually for your meter, I think, if I remember right. For your high voltage meter, they're going to string these in a series so that it drops the voltage down to a usable range for the meter. This is some kind of it's a what do you call this thing? It's resistor, but it's a really fine. This one's actually going to go in line with your high voltage. It's a 1 ohm resistor. That's a Darlington transistor. But anyways, this will go in. I think it's going to go somewhere in. We'll figure that out. I got the book, but and plus too, these leads are kind of long on this capacitor. When I put the board in, there should be standoffs that'll hold this off, but I'll make sure that that's not going to get anywhere close to ground, because you don't want an arc. DC high voltage likes to arc. So let's go ahead and start working on our bleeder resistor section. So we're moving along. Like I say, I've got one in the bleeder resistor section, and it doesn't really matter which direction these go in, but just being the anal retentive person that you need to be when you're messing with electronics, because that's part of the game, it seems to be. I don't know, it makes the ham operators really happy when they see stuff like this. I will make the effort and try to make the indication or writing on the resistor aim one way, and we'll stand, like I say, these actually will put off a little bit of heat because they're constantly trying to short the circuit, which is what their job is. So we'll give them a little bit of room off the board, just like we did the diodes. We'll do that too, just make things happy. And we'll just kind of lay things out like I did before, make it look good, like I say. That way when the guy opens the lid on this thing, he can be like, "Aw." So we'll just keep laying these out, and then we'll flip it over, we'll get it soldered in. Like I say, just trying to make it look good. That's basically, we'll just keep doing that. That needs to come down a little bit. There we go. I want that to be even, like that. Looking good. We're just going to keep going across the row like that. So we'll go ahead and get these soldered in. These little leads here don't have to get so hot, so it's going to go, it should go a little faster. And stuff there. Let's see. Clean into this. Like I say, you actually get, when you get solder on something, it really makes the heat transfer. And like I say, I won't do each one at the same time. I'll move along. That way it gives it time for the heat to get away from it. Plus I can flip it over and make some adjustments if I need to make them. I want them all look nice and level and happy. So we'll just keep going along till we do that, and we'll move to the next row. I'm gonna flip it over and make sure they're all even though. I'll show you. Do our clippings. My fingers are gonna be in the way. Get rid. That's why I like these little nippers like that. They get nice and tight to the board. Just keep doing that till we get all of them. A lot of little leads there. There we go. Our bleeders are in. Now we're going to put in these right here for the meter section. I think that's what this is for. And we'll do the same thing. We'll just kind of get these off of the little rubbers, the little things that are holding it, whatever you want to call it, the packing. We'll do some nice little bend down. These are nice and easy to move. And I want to put these all aimed one way just to make it look really good, you know, because I've got a 4-banded resistor with our tolerance at the end here, so I'll put them all one way. That's the main goal here. And being there, like I say, their main design is to be restrictive of electrical current, which means there will be some heat. So we'll go ahead and, like I say, give it a nice little standoff, the even standoff here. I want this to look good. So basically, there we go. We'll keep moving along with that till we get these looking all nice and pretty. And like I say, they're all going to go one way. Doesn't matter, but it just makes it look good. Put a little bit of solder on it. I got my end cleaned off now. It's nice and pretty now. That was dirty. Like I said, I like to skip just to keep from heat soaking too much on just the one. Looking good. Okay. Clean that off. I'm going to clip these off. There we have it. There's our metering things, metering resistors looking good. Next, we've got a couple little oddballs that'll go in here, and I'll have to look at my parts list. So R7 designation R7. That's the 910 watt 2 ohm resistor, which it would be this one right here, I do believe. But we'll take our meter and check it though. 910 ohm 2 watt resistor goes in R7, so we're gonna make sure we get that right. Go into our resistance mode. What was that? Yeah, that's a 900 ohm. That's close enough. 910 ohm. So that goes in R7. Right here. What I'll do is I'll give you a visual of the board of what it's supposed to look like after it's all assembled. Like I say, I like to I do like to space them off a little bit, give them a little breathing room. 910 ohm, you know, that's what that is there. And then the next one, you can tell it's a 2-watt resistor because it's a lot bigger than the rest that's in the kit. R8. R8. On the book here, it's our 3.6 kilo ohm half-watt resistor. So we got to look for a 3.6. And I mean, there's a color code, but I'm just using my meter because I'm cheating. Yep. There it is right here. This is going to go in R8. Right here. Okay. R9 is our 1 ohm 3-watt resistor right here. I have in my possession another one of these resistors. It doesn't want to see here. We'll just see what is this. $14K. That might have made it in the kit by accident. I don't see where it goes on this board, but I got a 14K resistor. I'll check this over real good before we finalize it. Put this in here. I guess I'm giving it a nice little breathing room. Then we'll solder that in. We'll double check to make sure that's what we're supposed to do here. I'm going to make sure of that. Then I'll give you a visual of the board, the finished product. So if you're doing this at home, you'll know, you can take a screenshot. You can look and see what I did. And referencing this 14 or 15K resistor, this 14 something. By the way, just to give you an FYI, when you're testing resistors, a lot of the times they're not always going to say, you know, this one calls for a 910 ohm 2-watt resistor right here in that R7 area. When you test it, you're lucky to get that. You're going to see about 900 ohms. Maybe you might see 915. You might see 898. Normal for resistors to be off a little bit, even if it's a gold banded. This is the beauty of the new style of stuff, metal oxide instead of carbon resistors. Carbon resistors were a lot better, but they don't make those anymore. So you have to kind of, we're having to deal with that. But this even in the little sheet right here, it even says it right here, 15K ohm right here. If you can see where I'm pointing at, it's NA, not applicable. They just probably throw it in this kit because it's universal for a lot of different things. So that's pretty much ready to be soldered. It's ready to be replaced and put into the machine. This is what it looks like right here. So if you guys want to take a screenshot of that. And to me, this is actually a work of art. I love to do this. I love to put these things together. I've built a lot of audio amplifiers for people and kits just because I like to solder things together and just putting the pieces. It's to me, it's just art. But that's what that looks like there. And like I say, this 1 ohm resistor, it's going to be tied in line with your high voltage. That's what you're going to see there. I think that's what that's for. That's just to kind of like make sort of a current limiter, or to keep it, to keep sometimes from having oscillation, run away from itself, especially when it comes to RF amplification. And so basically that's it. That's what the bottom side looks like. And we may trim some of that off if those leads look like they're too close to anything metal. These for the capacitors, you can kind of see in the light I got right here. But anyways, all right. So that's I guess I'll do a part 1 and part 2. That way it's not too long, and some people don't want to look at all that other stuff. So we'll call this a part 1, and then we'll do an install and do a part 2 with that.